Welcome to FHIR Mapping Language. I'm your host, Melinda Stewart from HL7. I'd like to introduce our speakers for today, Alexander Zautke and Vadim Peretokin from FHIR. Our moderator on the Whova app is Matthijs van der Wielen, and I'll now turn it over to Alexander.
Thank you so much. Yeah, hi everyone. Thank you so much for joining me here today. I hope by now everybody who wanted to join this session on the Let's Build FHIR Mapping Language has found their way into the channel after that keynote. So, my name is Alex Zautke. I work for FHIR on the FHIR server team. At FHIR, we try to implement FHIR native solutions for many of the challenges that you may encounter when implementing FHIR in a production environment. And one of these challenges is, how do I get data into my FHIR server? In many clinical settings, you are dealing and will be dealing for a long time, for example, with HL7v2 data, CCDA documents, or even Microsoft Excel CSV content. Therefore, we thought, wouldn't it be great to have a solution with which you could import more or less arbitrary data into your FHIR server? And for that purpose, we've implemented the FHIR mapping language into our FHIR server Vonk. After today's Let's Build session, you will know how to use two custom operations, namely $convert and $transform, to transform all these different types of data and load that up into your FHIR server. I hope you all attended the excellent presentation from my colleague Vadim yesterday on the introduction of the FHIR mapping language. If not, I would highly recommend that you watch the recording of that session from yesterday. If you have missed that introduction, don't worry, we will do a quick intro into the two most important parts of the FHIR mapping language, which is $convert and $transform. So you will still know on how the overall operations are supposed to work together and how the mapping process will look like in the end. Afterwards, we're going to take a deep dive into three different topics. First, we are going to have a look on how to transform a custom FHIR resource into a set of standardized FHIR resources. Afterwards, we are going to see how to incorporate concept maps into the whole mapping process to transform codes between different code systems. And last but not least, we will have a look on how to natively map CSV content to FHIR. If you have any questions during the presentation, please feel free to use the Q&A box for that. My colleague Vadim will try to answer any questions as you go along. And between each of these blocks, we will also have some time to answer questions and a larger slot at the end as well. So with that, I would say we get started. How does the FHIR mapping language work? How does it supposed to look like? Well, the first important thing that you have to understand about the FHIR mapping language is that it stresses the importance of having structure definitions which define the source as well as the target definitions of your mappings. The reason for that is relatively simple. You don't want to attempt a whole and quite extensive transformation process only to realize, oh, there was already a syntactical or semantical issue to begin with. So you don't need to try to attempt the transformation process. And you can use all the standard mechanisms that are already available through the FHIR validators to check if everything is correct. Afterwards, the transformation process is structured into two steps. First, we are going to take a look on the $convert operation, which takes a set of mapping language rules, which are in a human-readable form, the FHIR mapping language, which define how to map the source data to our target data. Afterwards, we have to teach the FHIR server on how to interpret these rules. And we do that by converting the human-readable part into a set of machine-readable rules in the form of a FHIR structure map. All these mapping language rules are a one-to-one representation of a structure map, so there is no information loss between here. And we do the transformation by using $convert. Afterwards, we can use that structure map resource and use the FHIR RESTful API to store it via a put or post on any FHIR server that supports the structure map endpoint. And then at the second point, we have a different custom operation, which is $transform, which takes in the source and you post that against the structure map, and that will trigger the transformation process. And you will receive your newly transformed data, which you can then again validate to make sure that everything got transformed correctly, and then store that on your FHIR server. But enough with the theory about the FHIR mapping language. Let's do some practical examples. First of all, I created a Postman collection, which can be found under this link. I also posted the link to the Postman collection in the Q&A box, so you don't need to type that here now. You can find that in Wova. We will be using the FHIR Mapper, which is the .NET implementation of the FHIR mapping language throughout this presentation. At the end of the presentation, there's also a link to a Confluence page where it's described on how to use the official Java implementation of the FHIR mapping language. So if you're interested in that, please check it out. The FHIR Mapper is currently hosted at vonk.phir.ly, which is the public test server from FHIRly, which you can use now at DevDays and also afterwards, if you want to try out more examples later on. The first exercise on the Let's Build session was an example on how to create a structure map resource, which in the end was supposed to create an empty patient resource, maybe just filled in with patient.id set to a random UUID or some minimal example. So now we're going to switch over to Postman to see how we can build such a structure map based on a set of FHIR mapping language rules. I'm going to start off with a clean slate. So you can watch the recording afterwards to say how to configure the endpoint. First of all, you have to realize that Vonk is structured into two different databases. First, all the conformance resources live in a separate database, which is called the administration database. As structure maps are also defined by the standard, the FHIR standard, as conformance resources, they naturally live at that endpoint as well. So our $convert operation, which takes in the set of FHIR mapping language rules and transforms that to a structure map, can be found here under that URL. Afterwards, we have to tell the server that in the end, we are sending a set of FHIR mapping language rules, which you can indicate by a content type with text FHIR mapping. Please don't forget to include that shell set header at the end. Then we need to tell the FHIR server in which FHIR version we want to get back the structure map. Structure map didn't really change between S23 and R4, but there are still some minor differences. So you always have to know in which FHIR version you are implementing your structure map in. You can switch here between R4 and S23. That's up to you. Now, for the rest, I'm going to open up an example, because I don't want to type too much here. Every FHIR, a mapping file starts with a map statement. After the map statement, we can find the canonical URL, which identifies the structure map. Please note that this is not the URL where the FHIR map is being stored at the end, but it's really the canonical URL of the structure map in the end. Afterwards, it's followed by a URM readable title of the structure map name. which can be freely chosen. Now, the exercise was also to include some metadata for the structure map. In the FHIR mapping language, you can do that by including triple slashes at the beginning of the file. So here we are defining a set of metadata like the status of the structure map. You could also set that to active if you're really sure that your mapping is working and then that you want to publish your structure map, and set, for example, the version of the structure map. Now, every structure map needs to have at least a mapping group where you define what it's being mapped. The first group is always a bit special because it is a group that will get automatically called by $transform. Here you define what source gets passed into the structure map for the execution part and what is our output. Now, please note that every mapping group needs to have at least one mapping rule. It's invalid in a structure map to have an empty group. If I would now execute that statement, I would get back a server error saying I have an empty block in the following group, and the FHIR mapping language parser yells at me that is not allowed. So in the end, let's simply assign a UUID to, for example, here, bundle.id. Every mapping statement needs to have at least some part on the left-hand side. So here with the source statement, we are basically telling, I don't really care what is on the left-hand side. Please just execute whatever is on the right-hand side of the assignment. I always wanted to have a shortcut for that, like underscore or something, but so far that didn't make it to the language specification. So you have to pass in something here on the left-hand side. Right. I just noticed that the exercise was saying that we want to create a patient instead of a bundle. So maybe we change that to patient here as well. And now we can execute $convert, and we are getting back a structure map resource. And as you can see here, everything which is in our mapping file can also be found in the structure map. So we have a repeating element here, which is called group, which contains all the input definitions. And we have some rules below with the target definitions and so on. You don't need to really worry about how structure map is structured. It's a really complex resource that you really don't want to attempt writing by hand in JSON or XML or try to debug. So $convert in is your friend in that case. It's easier to write the map and then simply do the transformation part. Okay, and with that, I would say that we already finished, already finished the first exercise. We covered how to set the correct content types and the accept headers. We added some metadata to the structure map. And when we now execute the structure map, we should get back an empty patient record, which we can try out in a second when covering $transform. But are there any questions so far?
One question. This interpreter that you mentioned that uses .NET to interpret FHIR mapping language, is it available to review how it works?
The .NET implementation is closed source. It's not open source, but it's available as a REST API and also in its binary forms. but as I said, it's closed source, so you can't review the source code.
Thank you.
At the end of the presentation, there are links to the .NET implementation and how to get that installed on a local installation of your FHIR server if you're interested in running your own instance. Any other questions so far? Otherwise, we are going to move on to $transform.
Somebody tried the $convert operation, but they didn't fill in the base URL environment variable. So Postman gave an error about the invalid URI. Do you want to show them how to do that?
Yes, sure. So instead of base URL, you can simply use https vonk.fhir.ly, and that should work as well. Sorry if the environment is not included in the Postman collection. Okay, so I think moving on. Now we have our structure map, and now we want to execute the structure map. For that, we need some kind of input. And for the purpose of the exercise, we try to use and provide you with a custom FHIR resource. A custom FHIR resource is basically any collection that you can describe in a FHIR structure definition. You can use Forge to generate logical models, and then you can transform a logical model structure definition to a custom resource. A custom resource is handled in Vonk like any other resource type. So as we can see in a few seconds, when you post the structure definition, Vonk will automatically generate a endpoint for that resource, like it would be any other FHIR resource like patient or observation. So for example, in the Postman collection, you should have a setup folder. And here we are seeing a structure definition, which can be posted to administration/structure definition. And here we are saying, okay, I have some kind of resource, which is a type which didn't exist in FHIR before. Like any other FHIR resource, it inherits from domain resource, and it's a specialization. And basically afterwards, you can, in your differential using Forge, build up any elements that you like, use any FHIR types, use your own custom types, and so on. So you can model your data using the mechanisms provided by FHIR. And if we now try to do a GET request, like say I have fake patient directory, let's switch to FHIR4. You're saying that it's being queried like any other FHIR endpoint, like I would do use get patient. Meaning that I can also post any custom resource like I would normally do. So let's define some minimal input. My resource type, like patient and drug chart. And if we look back here at the presentation, we are seeing there's an element which is mandatory called MPI, which is a string. So for example, I could say MPI, oops, sorry, just 1, 2, 3, 4. And if I post that now, it should be accepted and created as a normal resource. So Vonk handles everything automatically for you in the background. And now we want to transform that as defined by our structure definition, structure map. For that, we are now using $transform. So previously, we stored the structure map under that endpoint. And now we can simply call $transform by posting our custom resource as the body to that operation. So if I now say $transform, we that is a different structure map. Quickly switch back to $convert. Yeah, I forgot one parameter. So the $convert operation has a persist option, which you could use. And basically what the persist option is telling, that it will take the last part of the canonical URL and use that as its ID. Meaning, yeah, now I get back 200. Okay, so now if I go to administration/structure map /FHIR Mapper tutorial R4, it should be that here. Yeah, now we are getting back the transformation process as we defined in our structure map. And here you can see that the ID is now being assigned a random UUID. So we covered what is a custom resource, how to post that to Vonk, and then provided the custom resource to $transform in the transformation process. And through that mechanism, you can define any XML, JSON as you like, as long as it's describable by a structure definition. Any questions so far?
Yeah, there's a question. Oh, you go.
Go ahead.
Yeah, please.
Is the base URL stored someplace as well?
Yes, I think if you go to one of the question and answers, there is a...
It's the Vonk public server URL question.
Yeah. You should be able to copy paste that.
No other questions so far, though.
No, perfect. Okay, then we can continue. Now, we can transform our custom resource into many different parts. And in the end, the FHIR Mapper wants you to collect that into a single bundle, which you can then send back to the client. So it's easily usable by the client again. So now we're trying to extend the current mapping by going through a few rules, which we can use an example on how to create more data items. Now, that part I would make a bit more interactive. Are there any of you who had already a look at the mapping file? And are there any specific requests to discuss some of the transformations in more detail?
We did have a question.
Yeah.
And they said, "Hi, Alex. Any performance tests for Vonk transformation? How many millions of resources for transform operations in a second?"
Millions, not quite. The largest installations that we have is a transformation from HL7 v2 to FHIR, and it roughly handles, without any issues, 100,000 messages per day. But so far, that is the largest production environment that we are running in.
Cool. No other questions so far.
Okay. Well, then maybe we go through the mapping file one by one. And if any one of you has any questions about a certain part of the mapping file, please let me know. Maybe we are going to pick a few special cases first and then move on. So the first important part that you have to understand about the FHIR mapping language is that you can only select for one mapping rule one level deep into the target. So as you can see here, we are wanting to transform something from the source side to bundle.entry, but we want that patient resource that we are creating as an empty patient here to be stored in bundle.entry.resource. Every comma that you can see here is basically a for each loop. So it wouldn't be allowed to say I want to move one level more here to bundle.entry.resource as resource and then do directly the assignment. You can only select one level deep, but you can basically chain as many sub-selects, so to say, after each other. Then we can move on maybe to a few functions that are of interest. For most of the data types, we have these convenient functions, like, for example, here for ID to create an identifier. So most of the often used parts of an identifier, like the system or its value, can be directly passed to the constructor of the data type. Of course, you can create these data types manually by saying create and then type in the data type name here. So, but for most of the data types, there exist these convenience overloads. The data function is a bit special because the FHIR mapping language specification is relatively new. There are still some parts which are not that well documented, and the data function is such a case. So the parameters to date up are basically implemented only in the .NET API. The Java implementation might have different parameters available. But here is the second function. You can tell the target to create a date, but you could also choose to say, I want to have a date time if the data type of that target would match. Right. Still no questions about some parts of the map that we should discuss?
So no questions about the map, but there were two other questions. One is the mapper specific to Vonk, or can it be used with other tech stacks?
It can be used independently of Vonk. The REST API of the FHIR Mapper is bundled together with Vonk. However, it can be used as an API. As I said before, we could distribute the binaries and then you can embed that into your own .NET program. It's written in .NET Core, so it can be run cross-platform.
Yeah, and the other question was, Do you have any real-world examples that make use of a FHIR mapping language?
In the end, we are going to cover on how to transform CSV content, and that is as real-world as it can get today. Maybe as a follow-up, I could try to look up some examples on Simplifier. So on Simplifier, you can share your mapping files, and there are some open source projects who are producing mapping files. So there is a HS7 program going on GitHub where people are trying to map CCDA documents to FHIR, as well as the HS7 v2 to FHIR transformation project is also thinking about producing structure maps. They haven't decided on that yet, but there are still, there are definitely some real-world examples that can be looked at. I will try to gather some URLs and post that in the question and answer box afterwards. Okay. Moving on to one more special function, which is the $translate function, which is kind of special because it now involves transforming not only the structure of a resource, but you can also transform the content. So we can map between different code systems here. All that is based on the concept map resource. If you're new to concept maps, there are some talks this week about how to create concept maps, and there's, for example, here is a link to a tool called Snapper, which is created by CSIRO, which is a really easy to use tool for creating concept maps. And these concept maps can then also be shared on Simplifier. So for our example here, we have a structure map which maps all the different kinds of gender for the fake inpatient drug chart. So we have a few options here. And in the end, in the mapping file, we can then reach out to its own terminology implementation of $translate. So here we are saying I want to map the source gender to the official value set from the HS7 patient. So we load up the translate function with our value, then specify the concept map and say at the end we want to get back a code. You can pass any of the terminology data types here. So you could say I want to get back a coding or codable concept. So translate will handle that automatically for you depending on the output data type. So at the end we can now again maybe try that out. So we stored back the structure map. And if we are now executing the whole structure map again, you can see here. That was not the complete input. Gender. Here it transformed the input data using the structure map. Because we are running a bit out of time, I would simply cover for now the transformation process to CSV. So you have seen that once. Please feel free to use the question and answer box for any questions that you may have, and I will get back to you directly. And we can also schedule a different meeting to discuss some mapping issues in detail. So feel free to reach out to me. So just to show that, in the end, what it does when you post a CSV content, you can post that natively. So here we have the first row is the definition row of our CSV file, and then we have some content. And it will automatically generate the FHIR structure definition for you in the background, so you don't have to create your logical model for that content. And then you can use the structure map again to select different content based on the logical model being generated, as you would do it if it would have been created manually. So then we can natively post that to Wonk, and it will be automatically transformed like we did in the previous examples. And with that, I think we are almost out of time. Yeah. So thank you so much for joining me here today. If you have any questions, yeah, please let me know.
Yes, thank you so much to our speakers, Alexander and Vadim from FHIR. You can continue to ask questions and post those in the app, and our moderator, Matthijs, will help you out. Thank you so much, Matthijs, for joining us as well. And thank you to everyone for joining us for this session, FHIR Mapping Language. And we hope you have a great rest of the day.